This video will cover the topic, translating the graph of a logarithmic function. Remember that translation is taking an original function and moving it a certain amount of spaces vertically and horizontally. It may also involve stretching or compressing the original function by a certain factor. This video will show us how to take a given logarithmic graph and translate it to create a new function. Let's take a look at a given graph. Below is the graph of y equals log base 2 of x. Translate it to become the graph of y equals log base 2 of x plus 4 plus 1. Do you remember what we look for when translating vertically and horizontally?
I remember that if there is a number added directly to the x in the parentheses, then this means that the graph moves to the left the number of places that was added to x. And if a number is subtracted in the parentheses, then the graph moves to the right the number of places, right?
Yes. And what about vertical translations?
If there is a number added to the whole function outside the parentheses, then the graph moves vertically upward the number of places that was added, and it moves downward if there was a number subtracted outside the parentheses.
Yes, you've got it. That means you will already know how to translate this function. Based on your knowledge of translation, how would we translate this graph?
It appears that this graph moves to the left 4 spaces and up 1 space.
That is correct. Once the graph is in this new location, its function will indeed be y equals log base 2 of x plus 4 plus 1. Here's a picture of the final graph. See here that the point 1, 0 was translated 4 units to the left and 1 unit up. And in Alex, this is what you would do. You would click on the point and drag it to the new space. Now, if we were translating the graph by hand, we would need to find several more points on the original graph and translate each one individually, like 1/4, -2, 1/2, -1, 2, 1, and 4, 2. And we would find these by plugging in these values of x into the original function and finding y values. We chose these x values because they are smart values that calculate smoothly with log base 2. We then move each point to the left 4 spaces and up 1 space, resulting in -15/4, -1, -7/2, 0, -2, 2, and 0, 3. Using these points, we would then be able to draw our graph.
So horizontal translations are inside the parentheses and vertical translations are outside the parentheses.
Very good. You learn quickly.